And why the speed of light is not a speed. Let me tell you something that has bothered me for 50 years. Something that every physics textbook gets subtly, profoundly wrong. Not wrong in the equations. And the equations are fine. Wrong in the interpretation. Wrong in what they tell you it means. We call it the speed of light. We teach it as the speed of light. And we have built an entire civilization of scientific communication around the phrase, the speed of light. And that phrase, that single innocent phrase, is one of the most misleading things in the history of science. C is not a speed, not in the way you think speed means, and not in the way your car has a speed, not in the way a baseball has a speed. C is something deeper, something stranger, something so fundamental that calling it a speed is like calling gravity a push. And technically, you can make an argument, but you've missed the entire point. I'm Leonard Susskind, and I've spent my career inside the mathematics of space-time, quantum fields, black holes, the structure of reality at its most basic level. And I want to tell you what C actually is. And because once you understand it, really understand it, the universe stops looking like a place where things happen and starts looking like something else entirely. And something that has no good name in ordinary language. Let's start with what you think you know. You were taught that light travels at approximately 300,000 kilometers per second in a vacuum. And you were taught that nothing can go faster than this. You were taught that Einstein discovered this limit and built his theory of relativity around it. And you probably walked away thinking, okay, the universe has a speed limit, like a cosmic highway with a maximum velocity. Light is just fast enough to hit that limit perfectly. And that story is not wrong exactly, but it is deeply, catastrophically incomplete. Here's the first thing that should disturb you. And the number 300,000 kilometers per second is not a fundamental fact about nature. It is an artifact of how we chose to measure things. And if we measured distance in miles, C would be 186,000 miles per second. If we measured distance in light years and time in years, C would be exactly 1. Just the number 1. No units, just 1. And that last one is the important one because physicists who work in the right unit system don't think of C as a large number. They think of it as 1. It's a pure, dimensionless, unit-free fact about the universe, not a speed, a ratio, a conversion factor. A conversion factor between what? Between space and time. This is where everything changes. And when Einstein wrote down special relativity in 1905, he wasn't fundamentally talking about light. He was talking about the geometry of space-time. And he was discovering that space and time are not two separate things. They are two aspects of a single four-dimensional structure, a manifold, a fabric. And call it what you want, but the key is this. Space and time are made of the same stuff, and C is simply the exchange rate between them. Think about currency. And so if you're traveling between two countries, there's an exchange rate that converts dollars to euros. That exchange rate is not itself a dollar or a euro. It's a relationship, a ratio. And it tells you how much of one thing equals how much of another thing. C does the same thing for space and time. It tells you how much space equals how much time. And so 1 second of time equals 300,000 kilometers of space. That's what C means. Not that light is fast, that space and time are related by this ratio. And here's the truly disorienting implication. And if C is just a conversion factor between space and time, then in some sense, space and time are the same dimension measured in different units. And the only reason we invented two different words, space and time, is that we evolved brains that experience them differently. We can move freely through space in 3 directions, and we seem to be carried in one direction through time. This asymmetry in our experience made us think they were fundamentally different things. They are not. They are unified, and C is the unification constant. Now let me push this further, because there is a deeper strangeness here that almost nobody talks about. And if C is a conversion factor and not a speed, why does light specifically travel at exactly C? Why not some other speed? And why does light hit the cosmic maximum perfectly every single time, in every direction, in every vacuum, without exception? The answer will sound too simple. It will sound like a trick. But it is not a trick. It is one of the most profound facts in physics. Light travels at C because light has no mass, and massless things don't have a choice. Here's what I mean. In space-time, everything that exists is moving through the four-dimensional structure at all times, not just moving through space and time combined. And there's a rule built into the geometry of space-time about how this four-dimensional motion works. And every object, every particle, every field moves through space-time at a total combined rate that is always exactly c, always without exception. But here's the crucial part. The way that total motion is distributed between space and time depends on mass. When you're sitting still in your chair, you're not moving through space at all, but you're moving through time. And your rate of motion through time is exactly c. All of your space-time motion is in the time direction. None of it is in a space direction. And when you start moving through space, something has to give because your total four-dimensional speed must remain c. So as you gain speed through space, you lose speed through time. This is not a metaphor. This is the literal geometric mechanism behind time dilation. The faster you move through space, the slower you move through time. The two are trading off. They must trade off. And it's because c is fixed. Now push this to the extreme. Imagine an object with zero mass. An object with no mass has no resistance to being pushed to higher and higher space speeds. And so it gets pushed all the way to c in the space direction, which means it has zero speed left in the time direction. It is moving entirely through space and not at all through time. And this is why photons don't age. This is why, from a photon's perspective, no time passes during its journey across the universe. It has traded all of its time motion for space motion. And it has hit the geometric limit. It is traveling at c through space because it has nothing left to give to the time direction. c is not a speed limit. It is a geometric constraint. And it is the total budget of four-dimensional motion that every object in the universe is allocated. And that budget is c. And you cannot exceed c in the space direction because exceeding c would require borrowing from a time budget that doesn't exist. It would require negative motion. Through time, it would require going backward in time just to maintain the geometry. And causality, the requirement that causes precede effects, makes this impossible in a self-consistent universe. And so the speed of light is not a speed limit. The way a government posts a speed limit on a highway, it's more like the constraint that an angle cannot exceed 90 degrees while still being an angle. It's not enforced by a cop, it's enforced by the logic of the structure itself. Let me now tell you the part that most people never hear, c, is not even really about light. I said this earlier, but I want to be precise about it. c would exist in the universe even if there were no such thing as light. And c would be the geometric conversion constant between space and time, even in a universe with no photons, no electromagnetic field, no light of any kind. And any massless particle, any particle with no mass whatsoever, would travel at c. It has no choice. The geometry demands it. We call it the speed of light for purely historical reasons. And it's because light was the first massless thing we studied. Because Maxwell worked out the equations of electromagnetism in the 1860s and found that electromagnetic waves propagate at a specific speed. And when he calculated that speed from the properties of electricity and magnetism, it came out matching the measured speed of light exactly, which told him that light was an electromagnetic wave. And then Einstein came along and realized that c wasn't a property of light or even of electromagnetism. It was a property of space-time itself, the geometry of the universe, hence the conversion factor between its dimensions. But the name stuck, the speed of light, even though it was never fundamentally about light. There's a way of writing physics where c never appears at all. Hence, where you choose your units so that c equals 1, and then every equation becomes cleaner, every relationship becomes more transparent, and light disappears from the story entirely. Hence, what's left is just geometry, pure, clean, four-dimensional geometry. And the geometry tells you everything. But I want to dwell on this for a moment longer, because the implications are genuinely staggering, and most people rush past them. If c is a geometric conversion factor and not a speed, then faster than light travel is not forbidden the way speeding is forbidden on a highway. It is forbidden the way drawing a square circle is forbidden. It is not a rule, it is a geometric impossibility. The geometry of space-time simply does not contain the category of things moving faster than c through space. There is no slot in the structure for such a thing. And so it would be like asking for a direction that is simultaneously north and south. The question isn't illegal, it's incoherent. And wormholes and warp drives, those beloved staples of science fiction, don't get around this by going faster than c. They attempt to get around it by changing the geometry itself. Hence, by bending space-time so the two distant points become locally close, by folding the fabric so the gap disappears. And this is technically not forbidden by the C constraint because you're not moving through space at C plus something. You're changing what space means in that region. But here's the brutal reality. And to do this in general relativity requires something called exotic matter, with negative energy density. We have never observed such a thing. And the quantum vacuum produces something that looks superficially similar in the Casimir effect, but the numbers don't come close to what you would need to hold a macroscopic wormhole open. And it's not even in the same universe of possibility. So while the equations permit wormholes as mathematical solutions, actually creating one remains, as far as we understand, physically out of reach. And the geometry permits the idea. Nature refuses to provide the tools. And notice something beautiful and terrible about this. And the very fact that C is a geometric constraint rather than a speed limit means that the prohibition on faster than light travel is deeper than we usually describe it. It doesn't matter how advanced your technology becomes. It doesn't matter how much energy your civilization can harness. You're not fighting against a limit that better engineering might overcome. And you're fighting against the shape of space-time itself. The universe is not saying no because you haven't tried hard enough. And the universe is saying no because the concept you're reaching for doesn't fit inside the structure of reality. Now, let me go even deeper. And because there is a question that bothers physicists in a way they don't always admit publicly. Why is C the value it is? Why 300,000 kilometers per second? Why not twice that? Why not half? And so what determined this particular exchange rate between space and time? The honest answer is, we don't fully know. We know that if C were different, the universe would be profoundly different. And the fine structure constant, which governs how strongly light interacts with matter, depends on C. If C were significantly different, atoms would have different sizes. Chemical bonds would have different strengths. Stars would burn at different rates. And the universe as we know it, with its particular chemistry and its particular stars and its particular possibility of life, would not exist. This is what physicists call a fine-tuning problem. And the constants of nature appear to be tuned to values that allow for complexity, for structure. For us, some physicists think there's a deeper theory that will explain where C comes from. It's a theory of everything that derives C from first principles, a theory where C is not an input but an output, where the geometry of space-time is itself explained rather than assumed. And so we don't have that theory yet. Others think we live in a multiverse, a landscape of possible universes with different values of the constants. And we find ourselves in one with this particular value of C simply because this is the value that allows us to exist. No deeper explanation, just selection. And so I have gone back and forth on this for decades. I helped develop the string theory landscape, which is one version of the multiverse idea. I find it intellectually uncomfortable, but possibly correct. The universe doesn't owe us an explanation of its constants. It just has them. But here's what I want you to take away from all of this. And when you look at a beam of light, you're not looking at something traveling fast. You're looking at geometry in motion. And you're looking at a thing with no mass and therefore no choice but to move through space at the full geometric budget of the universe. And so you're looking at the conversion factor between time and space made visible. And so when GPS satellites need to correct for the fact that clocks run faster in orbit than on the ground, they are correcting for the geometry of space-time. And for the fact that moving through space trades off against moving through time at an exchange rate of exactly C. This is not an abstract theoretical nicety. It is a practical engineering reality. And without accounting for C as a geometric conversion factor, GPS would drift by kilometers within hours. When physicists write E equals MC², the C² is not telling you about light. It is telling you that energy and mass are the same thing expressed in different units, and that C² is the conversion factor between them, between mass units and energy units. And it's between a kilogram and a joule. C is doing unit conversion, not speed. This is what C really is, not a cosmic speed limit, not a property of light, a geometric fact about space-time. And it's the exchange rate between dimensions, and it's the conversion constant that tells you how much space equals how much time, how much mass equals how much energy, how fast a massless particle must travel, because geometry leaves it no choice. And so we gave it the wrong name. We called it the speed of light, because that's how we stumbled onto it. Historically, accidentally, and it's the way humans often stumble onto deep truths, not by deduction from first principles, but by tripping over them in the dark and then slowly, painfully recognizing what they actually found. And what we found was the geometry of the universe, and that geometry is stranger than any speed. It is stranger than any limit. And it is the structure inside which space and time and mass and energy and everything we have ever observed are all embedded, all unified, all connected by a single number that we happen to call c. And it's not because it is the speed of light, but because it is the shape of everything. There's one more thing I want to say before I close, because it connects to something deeply human. And so we measure things by giving them names. We name them after the first context in which we notice them: the speed of light, the force of gravity, the laws of physics. And each of these names carries a shadow of the original confusion, the original limited perspective from which we stumbled onto something much bigger than we realized at the time. And gravity is not really a force. It is the curvature of space-time. But we called it a force because that's what it felt like to Newton when the apple fell. And we have been dragging that misleading name around for centuries. The laws of physics are not really laws. They are descriptions of regularities in a structure we don't fully understand. But we call them laws because that's the language of authority and certainty that 17th century scientists reached for when they wanted to sound like they knew what they were talking about. And c is not really a speed. It is the geometric signature of the space-time we inhabit. But we called it the speed of light because James Clerk Maxwell computed it from electromagnetic theory, and it matched the measured velocity of light, and that felt like a sufficient description at this time. The names we give things shape how we think about them. The name speed of light makes you imagine something zooming through space very quickly. It puts your intuition in the wrong place. It makes you think the mystery is about velocity rather than about geometry. Once you see it as geometry, everything reorganizes. Time dilation is not a paradox. It is a geometric consequence. The Lorentz contraction of objects at high speeds is not a physical compression. It is a geometric rotation in space-time. E equals MC² is not a mysterious formula about nuclear explosions. It is a statement about two different ways of measuring the same geometric quantity. All of it falls into place when you understand that c is not a speed, and that it is instead the conversion factor between the dimensions of a unified structure, the number that tells space how much it equals in time, the number that tells mass how much it equals in energy, and it's the exchange rate of reality. And here's something I find quietly extraordinary about this fact. The universe did not have to be this way. And you can write down mathematically consistent geometries where space and time do not unify, where there is no c, where the exchange rate between dimensions simply does not exist. In such a universe, mass could not convert to energy. Massless particles would not be constrained to a particular velocity. Time and space would be forever separate. And the universe would be utterly unlike ours. The fact that our universe has a c, a single clean conversion constant connecting its dimensions, means our universe has a particular kind of geometry. It's Minkowski geometry. We call it after the mathematician who first wrote it down clearly. And it is a geometry with a very specific symmetry, a symmetry between certain spatial directions and the time direction. And that symmetry is why the universe looks the same to all observers, regardless of how fast they're moving. And it's why the laws of physics don't change when you're in a car versus standing still versus orbiting in a satellite. The symmetry is in the geometry, and c is its numerical signature. And we did not choose this geometry. We were born into it. We evolved inside it. Our brains are shaped by it without knowing it. And when you throw a ball and intuitively know where it will land, you're doing geometry in your head, geometry of a space-time with a specific c, even though you have never consciously thought about any of this. C is in you too. Your atoms are held together by electromagnetic forces that propagate at c, and the nuclear reactions in the sun that produce the light hitting your face right now run at rates determined by c. And the information in your neurons travels at speeds far below c, but within a universe whose structure c defines. You're not just observing a universe shaped by c, and you're made of processes that happen within the structure c describes. And light, the thing we name c after, is simply what happens when you have a massless excitation of the electromagnetic field. A ripple in a field with no mass, constrained by geometry to travel at the only rate a massless thing can travel. It is beautiful, and it is strange, and it has been misnamed for a century and a half. And I have spent 50 years inside the mathematics of this structure, And I still find it astonishing. Not the number itself, the number is just a conversion factor. What is astonishing is that space and time can be converted into each other at all, that the universe is built from a single unified fabric rather than two separate stages, and that the fact we experience time as different from space is a feature of our biology and not a feature of reality. Reality is a four-dimensional geometry. C is its signature, its fingerprint, and the number that tells you what kind of geometry you're living in. And light, massless and eternal from its own perspective, moving through space at the full geometric rate because it has no mass to slow it down. Light is just the most visible consequence of that geometry, the messenger that carries the news of C across the cosmos. It is not moving fast, it is moving at the only rate the geometry allows for something with no mass. And that finally is what C actually is, not a speed, never was.